All right, now we're going to give a couple of examples of recommender systems, Google News, and a brick and mortar shop. First, a couple of slides on Google News. Here's a February 3rd, 2014 example of my Google News. You'll see here various categories. You can choose which categories you want. Here we have top stories, and these are the topics here we have. I have one, because I select Bloomington, Indiana. I like New York Times. I have physics here because I like physics. I once went, there's Barack Obama, I forget now, in the Republican Party. That's probably a relic of when I was looking at the election, and various other standard categories which which are sort of made by Google for you. And the particular category I have is California Institute of Technology, where I was a professor for 20 years. So you choose categories, and you personalize it over here into these categories. And then given those categories, Google goes out there and finds out which news items fit those categories. And so it's trying to do so-called topic-based analysis. Is not really collaborative filtering, uses different technologies. In fact, it's definitely not collaborative filtering. It uses different technologies, but they're all optimization problems, and they're all machine learning. It's actually the method is nearer clustering than it is recommender systems. So here's a description from about the Google News portal. It now has 72 editions, 30 languages, 50,000 news sources. That's, New York Times, I assume, is one news source. And the same thing is done to give you Google News, which is a set of fixed topics with a certain number of items per topic, and News Search, where you type in a search criteria and it goes out to those news sources to find the result of that search. And I guess they have 1 billion users using this technology. That's a big number. And this uses what the user's done, what the larger community has done. And of course, it's a huge big data problem. There are lots of users, lots of articles, and you have to do this quickly. Remember that contract search engines have to give their answers in fractions of a second. I would say a second is quite long. And there's always a lot of streaming of new items. There's a whole new area of computer science which corresponds to processing streaming data, because so many of these fields we're looking at have data that just keeps on getting updated, either new items or updates of old items. And you must interact immediately with the user. The user expects that. And as I say, clustering, or what's called probabilistic latent semantic indexing, and this uses technology like MapReduce to actually process it and run a large parallel job to do this. So we don't really in this course have it's outside our scope to do these really beautifully interesting algorithms, but you just have to know that behind that Google News is an incredible amount of analytics, just as there is behind Netflix. But they're different analytics. Each of them has spent I don't know, thousands, tens of thousands of person years developing. And now after this, we'll go on to discuss bricks and mortar and how to decide to mark down, or I guess in principle mark up, how to price items in a retail store. Another example here from another talk given by SAS is that optimizing pricing in retail, you need obviously to make good profits. You need to always offer what the users want, which means you better get rid of the things they don't want. And so that requires a careful optimization in price. If you reduce the price too much, you lose too much money. If you reduce the price too little, you will not clear your apparel. And Points out here in the past this was often done by intuition, but now it can be done by actual analytics. This slide here points out the magnitude of the problem. 100 million decisions need to be made on pricing because we have so many stores and so many products, and that gives you up many terabytes of data each week, which correspond to looking at the last 2 years. And this gives you the number of units sold, the price, and so on, and how much inventory you actually have, and actually what you did to get rid of to popularize the item. And this is one of what I pointed out, an optimization problem. Here we're trying to optimize the sort of two variables, two functions. One is the money that the store gets, and the other is minimizing the amount of unsold product, because you obviously will get nothing if the product is absolutely totally unsold, unless you can return it to the manufacturer. And there are lots of things these depend on. The time of year, how exciting the product is, whether it's just come out or whether it's rather mature, and also what your history of promotion is. People don't buy things if you always discount and then you don't discount a particular item. So that's an important issue. And here's some rules of thumb, such as 80% is the lowest possible markdown. And also these psychological things like $1.99 is a lot less than $2 in people's mind. And also you have to disentangle various competing effects. And finally, as we see on some data we present following, within any one store, the sales data are pretty sparse, and so you can't make a very good prediction based on that. Here's this example of noisy data at the store product level. This is one store on one product, and you can see the units sold on a monthly basis. Well, these are probably weekly basis. On a weekly basis, are measured in the ones and twos. And here you're trying to make predictions on the amount sold as a function of the price. So you have to try to group this data together based on groupings within products or groupings within geographical groupings, or maybe just other types of groupings. If two stores are in different geographic locations but have the same type of customer, then they probably should be related to, they could be joined together. So anyway, you need to aggregate data in an intelligent way, and here's an example of aggregated at the region level and showing the relationship between price and sales volume. This can be used to then predict what price you should set if you wish to increase the sales.